Good morning. I just wanted to go over the end of lesson 4 with you, the independent practice. We're supposed to be doing number 7 through 12, 19 through 21, and 23 through 32. I'm just going to do a couple problems from each section and let you watch the guided practice videos and work on it on your own since it is independent practice. However, I've gone over many examples of how to complete the problems. So if you need any help, uh, don't hesitate to call me or text me. Definitely schedule time with our tutor outside of class as well. But anyways, let's begin. So we have for problems 7 through 12, there's a diagram that has a rhombus A, B, C, D, and two diagonals that intersect at E. Essentially, number 7 says the measurement of DAE, so we have to go DAE, so this measurement right here is equal to 25. And it says find the measurement of DAB. So I want you to find this measurement right here. So we know that this measurement is 25 degrees, and it wants us to find X right there. So essentially, this is a type of problem that uses the properties of a rhombus, and what we are going to do is look at the properties of a rhombus, and this is on page, let me look to tell you the specific page so you can verify it. So essentially, this is from page, I believe, 830 in your book. It's theorem 13.14, so this is from page 813, and it's theorem 13.4. And what it says is that if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So if this bisects these two angles, that means that these two angles, the measurement of DAE, is congruent to the measurement of DAB. So since DAE is 25, that means that X is also equal to 25 degrees. So the measurement of DAB is also equal to 25 degrees because of its theorem 13.14. So this is because of theorem 13.14. All right, so it says DC, our second problem, number 8, says that diagonal DC, sorry, not diagonal DC, I thought it was the diagonal, but DC is down here. It says that DC is 12, and we want to find AD. Well, in a rhombus property is just like a square, meaning that all sides of the rhombus are equal to each other. They're congruent. So what that means is when we look at that, this is from page 832, theorem 13.17. So this is page 832, and this is theorem 13.17. And I'm sorry, I must have read the page wrong. For number 7, the page is actually 830, but the theorem is correct. It's in the section that we're going over. So essentially, AD is going to be congruent to DC. So it's going to also equal 12 because these sides are congruent in a rhombus according to theorem 13.17. All right, so the next problem says AE AE right here is 5x minus 3, and AC, the whole entire thing right here, is 7x. All right, and it says find DB. So I want you to find the other diagonal. So what we're going to do is we know that AE is half the length of AC. So since we're going to have 5x minus 3 plus EC is going to also be 5x minus 3. So what we could do is just add another 5x minus 3, and that's going to equal 7x. And that's because that's what the property states. I want to find it on, let's see the theorem. I don't know if they show you that. Let's see. Yeah, they don't show you the theorem. So essentially, we're just going to keep going. Let's combine like terms. 5x plus 5x is 10x. And I'm writing it on the wrong one. Okay. So we have 5x minus 3 plus 5x minus 3 equals 7x. So combining like terms, we get 10x. And then minus 3, that's minus 6 equals 7x. So then we're going to subtract 10x to both sides, and we're going to get negative 6 equals negative 3x. So then we're going to solve for x by dividing both sides by negative 3, and x equals 2. But that is not the length. The length of dB is going to equal the length of AC. And since AC equals 7x, we're just going to plug this value in for x. And we're going to have 7 times 2 equals 14. So the length of both the diagonals, AC and DB or BD, is equal to 14. And I know I put DB because I just went D to B, but it wants BD, which it's the same thing. I just wrote it going from here to here instead of like that. So that would be the length of the diagonal. And the only thing I want you to remember is that in a rhombus, these two parts of the diagonal where E is located are congruent. They're basically equal to each other. So that's how we did 5x minus 3 plus 5x minus 3 equals the entire length of 7x. All right, so let's keep going. So I want to now do problem 19. I'm just going to do one of them, and I want you to practice the other two. This was the same type of problem I just posted on the guided practice. There's some steps you have to take in order to do the problems. Let's see, 23 through 32. Actually, to save time, I want you to just practice 19, 20, and 21 on your own. Make sure you go back to problem 5 in the guided practice that I just posted online yesterday and really pay attention to the steps. That's the identical type of problem that these problem 19 through 21 are, but I've noticed that there are problems like 30 through 32 that was not in the guided practice. So in order to save time and really go over different types of problems, that are in your uh, basically homework. I want to definitely go over through like 30 and 32 right now. And if we have time, I'll go back to look at like problem 19. So it says classify each quadrilateral. So if we look at number 30, we can tell what kind of shape it is, not because of the way it's drawn, but that we have a congruent leg that's going to be congruent to the opposite leg, and another congruent leg that's opposite to the other congruent part, and then we have a right angle. So we know that this shape is going to be a rectangle, and that's because a 90-degree angle was formed, and that means that each of these vertices at the corners where the side lengths meet, they're 90 degrees. But because you have the congruent symbol where there's two slashes and one right here, that means that these two side lengths aren't the same. And I know the length basically demonstrates that, but if for some reason like the book wanted to draw it to where there was like a side length that looked like it was shorter than the other side length, um, they could also have one slash and it would actually be a square. But in this case, they drew two slashes and one, so that means that these two lengths are not the same, and therefore it would be classified as a rectangle. If it was one slash and every side length was the same and it formed a 90-degree angle, then we know it would have been classified as a square. So for number 31, we have, it looks like a parallelogram, but then we have these congruent parts. So like I did the problem in the last, it was problem, I believe it was 11, or actually no, sorry. It was problem, we just went over for the diagonals. Yeah, it was problem 11. Okay, so essentially it's the same type of situation. When we have diagonals and then they intersect at the center and then they create two congruent segments, we know that that's going to be classified as a rhombus. So we know that 31 is a rhombus because the diagonals create two congruent segments. And now 32. We have a 90-degree angle and we have two congruent segments like this. And essentially it wants us to classify what kind of shape that is. And I just wanted to see if in the book it has like a theorem, but it does not. So whenever you see a situation like this where we have congruent um, segments in the diagonals and then there's a 90-degree angle in the corner of the quadrilateral, or in this case it's a square because where this vertex is and the sides meet at this point, it forms a 90-degree angle. So if you have diagonals that have congruent segments and a 90-degree angle, that would be classified as a square. Okay, so I do have some more time before class starts, so I'm going to continue on with some more independent practice questions to help you get through this section. And then I'm going to be going over lesson 5 today and posting it to YouTube.